going to use trig substitution. This integral is relatively complicated. So first of all, we have a definite integral, and we're going from 2/5 to 4/5. And we're going to be integrating the function square root of 25x squared minus 4 all over x. So you should recognize that this is a trig substitution problem just from the fact that you have something squared plus or minus a number all under a radical. That should signify to you trig substitution. So what you want to think about is, which trig function do I choose? Well, our variable is squared and we're subtracting a number, so that means we use secant, because remember, secant squared minus 1 is the easy trig identity. But we're going to have to put a number in front of it. We can't just say x equals secant, because that won't work out. The best way to do this is think about, what number do I have to attach to the secant, so when I square it, it cancels out this 25 and I get 4, because then they'll both have 4 and I can take that out. Well, that means once it's squared, it would have to be 4 over 25, because the 25s would cancel, you'd stick with the 4. That means before you square it, it has to be 2 over 5. So this is going to be 2/5 secant theta as our substitution. So if that wasn't immediately clear to you, I think when we plug it back in, it will be. So let's take the derivative of both sides here. Dx equals, so the derivative of secant is just secant tangent, and this 2/5 is going to stay there. Secant theta, tan theta, d theta. So when we plug in our substitutions, let's see what we get. We're going to do the integral from 2/5 to 4/5. Excuse me. So 2/5 to 4/5. We're going to have 25, and instead of x, we're going to be putting 2/5 secant theta squared minus 4. On the bottom, we have x, and x is just 2/5 secant theta. And instead of dx, we have all of this. So we get 2/5 secant theta, tan theta, d theta. So our integral is pretty long right now, but as you can see, we get a decent amount of stuff canceling out here. 2/5 is in the top and the bottom. Secant theta is in the top and the bottom. So that all goes away. So let's deal with what's under the root now. So when we do 2/5 squared, we're going to get 4 over 25, and the 25s are going to cancel. So we're going to get 4 secant squared theta minus 4. And actually, I don't need to write it there because it's not a fraction anymore. We canceled out everything on the bottom. So we get 4 secant squared theta minus 4. And we still have a tan theta sitting here outside, d theta. Well, the 4's can be factored out, which would leave a 2. We'll get secant squared minus 1. So I'll write out that step before I go to the end here. We just get square root of secant squared theta minus 1, tan theta d theta. Secant squared minus 1, that's the whole purpose we chose secant in the first place, is because secant squared minus 1 is tangent theta, or sorry, tangent squared. And when we do the square root of tangent squared, we get tangent. We're going to have tangent times tangent there, so we're going to get tan squared. Okay, so now what this boiled down to is we're really just integrating tangent squared. Well, to integrate tangent squared, you actually want to convert it by the Pythagorean identity back to secant squared minus 1, because secant squared is a much easier integral to do. So instead of tangent squared, we're going to have secant squared theta minus 1 d theta. That antiderivative is very simple. The antiderivative of secant squared is tan theta. The antiderivative of 1 with respect to theta is theta. This is all times 2. Now we are going from 2/5 to 4/5, but that's in terms of x. So we have to plug back in for theta, and that's where this involves doing our right triangle. So let me draw that here. So we have a right triangle, and let's call theta this. So what you want to do when you get to this point in the problem is kind of rearrange what you trig sub just so that you have the function. This is saying that secant theta is equal to 5x over 2, if I just solve that for secant theta. That's saying that cosine theta is 2 over 5x, because secant and cosine are just reciprocals. So I just need to label this triangle correctly if cosine is 2 over 5x. So cosine is adjacent over hypotenuse, so that means this is 2, and that's 5x. I can figure out the other part by Pythagorean theorem. However, remember, that last part is always going to be what you ended up having under the root in your original problem. It always works out like that. This is going to be square root of 25x squared minus 4, because that's what we have here. You can also just do that by Pythagorean theorem. You'll get that. But that's what that always ends up like. So now we just need to consider what's going on here. Excuse me. So we have a couple of different things going on. We have tan theta and we have theta. So tan theta, we can just get straight from this triangle. Tan theta is just root 25x squared minus 4 over 2. Theta, on the other hand, is not going to be as simple because that is not something we can express as a trig function. We're kind of just going to have to do at one of our other types, just an inverse trig function. And since we have it set up here already, we can just say it's arc cosine of 2 over 5x. And this is going from 2/5 to 4/5. So keep in mind, for that theta, you could have called it arc any trig function as long as you did the ratio correctly. So that doesn't matter, actually. I just chose arc cosine because I had already written cosine here, and that seemed pretty simple. But you could have done it for any of the trig functions there. So now let's just plug in all of our values and see what we get here. Okay, so if we plug in, let's see, where am I here? So if we plug in 4/5, so we're going to get 25 4 over 5 squared minus 4 all over 2 minus arc cosine of 2 over 5 times 4 over 5. Let's see what that is, and then we'll figure out. Actually, let me just write the one for 2/5 as well, and then we can subtract them. Let me see what I want to erase here. So this would be minus what we get when we plug in 2/5. We get plug in 2/5, we get the following. I'm just going to write it out with it plugged in, and then we'll figure out what those actual terms are in a sec. Okay, so we get our cosine of, what are we getting here? 2 over 5 times 2/5. Yes. Okay. So let's see what happens when we actually solve for all of these numbers. Alright, so 4/5 squared would be 16 over 25. Times 25 gets rid of those. We get 16 minus 4, which is radical 12 over 2. 5 times 4/5, those 5 cancel out. We get 2 over 4, which is 1/2. Arc cosine of 1/2. So that's saying cosine of what is 1/2, and that would be pi over 3. So that's fully simplified when we plug in. Sorry, I should write this more clear. That's not a 2/5 power. That was what we were plugging in at the second number. So now, subtracted, we get 2 times. So let's see what we get here. 2/5 squared is 4 over 25. The 25's cancel. We get 4 minus 4. This term is 0. And let's see what happens here. 5 and this 5 cancel out. We get arc cosine of 2 over 2, arc cosine of 1. So we're saying cosine of what is 1? Cosine of 0 is 1. So we actually get 0 for that number too, which means the whole last part was just 0. If we multiply this 2 through, then we get root 12 minus 2 pi over 3. And root 12 is not the simplest form of that. You can factor out a 4, which would become a 2. So we get 2 radical 3 minus 2 pi over 3. Finally there at the end. So I mean, that was maybe as complicated as a trig function you could get on an exam in this class. But remember that which trig function you actually choose is determined by the order in which you're doing x squared minus a squared plus a squared minus x squared, those things, by the trig identity. So just memorize that table, make sure you know which trig function should be plugged into which case. And then if you need a number in front of it, it should be pretty obvious. The number is whatever, when you square it, whatever gets rid of any coefficient that was in front and makes the number match the number that's by itself, because that always has to be factored out. Just like in this case, they both ended up being 4s, we could factor that out and we get the identity. So you always have to end up with the identity. So you can always just choose your number so that you end up with the identity. Do your integral, and finally you always need to set that right triangle to get back to x instead of theta, or whatever the variable was. It didn't have to be x. But remember that if you end up with a theta like we did here, that is always just going to have to be represented as an inverse trig function. There's no way around that. But any trig function should always just be a function of x that doesn't involve any trig whatsoever once you plug back in.